Back in today's video, I'll take you through one of the most famous datasets in data science, the Titanic Survival Prediction Project. But instead of just coding, I'll show you how I use the crisp DM for data mining. We'll start from understanding the business problem and go all the way to deploying a predictive model. So let's dive right in. First, our business goal is simple: predict whether a passenger survived the Titanic disaster based on their demographic and ticket information. This analysis doesn't just build a model, it also helps understand patterns like how age, class, and gender affected survival chances. So here I uploaded the Titanic dataset into the collab. It has 891 rows and 12 columns. I use pandas to view data info and check missing values. We can see that age and cabin and embarked have some gaps. Then I plot histograms to explore survival rates, and immediately we noticed that women and first class passengers had the highest survival probability. Next is data preparation. This phase is all about cleaning and transforming the data. I fill the missing ages using median, fill missing embarkation ports with the most common one S, and drop the cabin column since it's most heavily. I also encode categorical features like sex and embarked using one hot encoding. At the end of this step, my data is clean, numeric, and ready for modeling. So now come the modeling phase. Now we build the model. I chose a random forest classifier for its reliability and interpretability. Using a scikit-learn pipeline, I handle pre-processing and model training together to avoid data leakage. After training on 80% of the data, the model achieved an accuracy of 83%, which is really good for this dataset. Now comes the evaluation phase. In this phase, I use metrics like precision, recall, F1 score, and accuracy to evaluate performance. The confusion matrix shows strong results and feature important plots highlight the top predictors: fare, age, P class, and sex. The model correctly learned that women and first class passengers were far more likely to survive. And finally, this is a mini deployment phase. Finally, I saved the trained model and pre-processing pipeline using joblib. This means I can reuse this anytime to predict survival probabilities for new passengers. The deployment phase turns out our model into a real usable tool. So that's the complete crisp DM pipeline in action, from business understanding to deployment. This project proves that structured methodologies make data science more reproducible, transparent, and impactful.